Hello and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 9. And the directions here are, one word, evaluate. Right? So in number 9, we are given a table of values. Our top row is our inputs. So we have some various x values that we can plug into two different functions, right? So the middle row represents what happens, what is the result of taking that x value and plugging it into the f function. And then the bottom row tells us what happens when we take a given input, x, and we plug it into the g function. So this is just another way of representing a function, right? You can represent a function using an equation. You can represent a function using a graph. You can represent a function using a table, right? So in this case, we're dealing with a function, two functions rather, f and g, and everything we know about the functions is based on this table. So let's go ahead and get started. Actually, for this, I'm actually not going to zoom in for this one. We're going to keep everything here. So for 9a, we want to evaluate f of 7. So this is just saying what is the result when you take 7 and you plug it into the f function. So we're taking 7, we're plugging it into f, so the result is 1. Okay. 9b. 9b is asking what is the result when we take a -2 and we plug it into the g function. So we're taking -2, we're plugging it into the g function, and the result is 0. Okay. 9c. 9c is asking what happens when we take a 1 and we plug it into the f function. So we're taking a 1, we plug it into f, and we get a 1 again. Right? Sometimes that happens, right? You can, plenty of times you can have a function, you plug it in, and it turns out that your output matches your input, right? So that's certainly possible. 9d. All right, so 9d. Notice that it's different from A, B, and C because you've got this kind of this -1 that kind of looks like an exponent on f. First of all, to be clear, that -1 is not an exponent. It's a superscript, but it's not saying like take f to the -1 power. Right? That's not what this represents. When you see this, this is an inverse. All right, this is f inverse of 6 is how you would say that. All right, f inverse of 6 with an inverse function, you swap your outputs and your inputs. All right, so your x's become y's and your y's become x's. Your outputs become inputs. Your inputs become x's or outputs. So with 9d, what this is asking is it's basically asking you to go backwards, and it's asking what is the input that if you were to plug that input into f, you would get a 6, right? So A, B, and C, it was almost like here's the question, what's the answer? With 9d, it's like here's the answer, what's the question? Kind of like Jeopardy, like the answers are in questions, right? So 9d is saying the result is 6. What is the input into f that would result in a 6? So we're examining the results of the f function, and we're trying to figure out, all right, we got a 6, but what was the input that allowed us to get that 6? And the answer to that question is a 9. So 9d, your answer is 9, because that is the input that when you plug it into f, you get a 6. That's what that question is asking. 9e, same thing as d, except we're working with the g function. Again, this -1 tells us that we have an inverse function, right? So it's saying that somehow, some way, we got a -5 as the result of plugging something into the g function. What is the input that resulted in that result of -5? So looking at the g function, all right, and I see a -5 as that result. So what is the x value that gives us -5? And it's 6. Brief note here, if we had more than one -5, like for example, if we had, like if this was -5, you wouldn't be able to answer that question, right? So this would be not a one-to-one, it would be a function, but it wouldn't be a one-to-one function. So you would not be able to answer that question because you would have multiple inputs that result in the same output, which again does not prevent it from being a function. It just means it's not a one-to-one function, and you can't have an inverse of a non-one-to-one function. So moving on, 9F. All right, 9F. You're going to want to look at 9F like from the inside out. All right, so you've got the brackets, and sometimes brackets throw off students. Well, maybe not most of the time, but a significant portion of the time, when you see brackets, that is just another way of sort of having nested parentheses, right? So sometimes, you might have something like this. I don't know, like that, where you have like parentheses within parentheses. But sometimes the outer parentheses are replaced with brackets just to like make it like even clearer as to like what is what, right? So that's what's happening in this context. So don't let the brackets throw you off. Just treat them as like the outer set of parentheses. But you want to work your way from the inside out. So what's happening here is you've got this g of 9, okay, which is just like A, B, or C, essentially. But then what's happening is once you get g of 9, it's asking you to square the result, okay? So I'm actually going to leave the squared alone for a second, right? And I just want to evaluate g of 9. Like, what is g of 9, right? So again, it's saying you take a 9, right? And this is not an inverse. This is just g of 9. So you take a 9, you plug it into the g function, and the result is a -4, right? We are evaluating g of 9. But then the second part of this is to then take that result of -4 and square it, okay? Now, if on the calculator, if you wanted to do this on the calculator, which I mean isn't really necessary, but just to be clear, if you are squaring a negative number, okay, remember that squaring means you're multiplying something by itself. So it's -4 times -4, which is +16, right? That's the correct answer. If you were to try to do this on the calculator, if you were to type in -4 squared like that, it's going to give you a -16, which is the wrong answer. Okay, and the reason is that if you ever want to square a negative, you need to include it in parentheses. All right, so just be very careful about that. Now, again, I don't really anticipate a lot of people would use a calculator for this, but just as a side note, whenever you square a negative on a calculator, you have to include it in parentheses, because the calculator, if you don't include parentheses, the calculator does the squaring first and then makes it negative, which is not what you want. All right, so just a quick little side note there. 9G. All right, this is where things get a little bit more interesting. So for 9G, kind of similar to F, you want to work from the inside out. This is a composition of functions, right? And we're definitely going to be working with composition of functions this year. So similar to 9F, for 9G, you want to work from the inside out, because what's happening here, if you wanted to say 9G out loud, you would say f of g of 13 is how you would say that, all right? So it's f of g of 13. So sort of conceptually, what's happening here is it's saying take the g function and plug in a 13. And you're going to get some result, right? We're going to get that in a second. And that's the output of G. But then what you're going to do is you're going to take that output, right, that was the result of the g function, and then you're going to immediately turn that around, and it's going to become the input into the f function. So I'm going to say that one more time. For 9g, sort of the original input is 13, and we're going to take 13, we're going to plug that into g, and we're going to get something. Okay, then we're going to take that something, and then that's going to immediately become the new input into the f function, and we're going to evaluate that, and then that's going to be our final answer. All right. So if that sounds complicated, I think once you see it, I think that you'll see kind of what's happening here. So we are taking 13, all right, and we are plugging it into g. And when you take 13 and you plug it into g, you get a -2. So what that means is I'm going to leave the f function alone for a second, and then I'm going to replace my g of 13 with what I just got, which was -2. So -2 was the output that resulted from plugging 13 into g. But now, as you can see, now I want f of -2. So that -2, which was an output, now I treat it like an input, right? Say, all right, what happens when you plug a -2 into something? So when I take a -2 and I plug it into f, I get an 8. So my final answer for 9g is 8. I took 13, I plugged it into g, I got -2. I took that -2, I plugged it into f, and I got 8. That's how composition of functions work. And in this case, we're using a table. Again, functions can be graphs, functions can be equations, but in this case, we have a table, so this is how you handle it when you're given a table. 9h, very similar to g. Let me erase all the previous circles. So with 9h, it's the same idea, except it's just kind of g and f have been flipped. But still, what's happening with h is we are taking 6 and we're plugging it into f. We're going to get something. That's an output of f. We take that output and then we treat that as our new input, right? That's like our new x almost. And then we take that former output, but now input, and we take that and we plug it into g, and then we evaluate it at g, and that's our answer. So I'm going to leave the g function alone for a second, right? Because you want to work from the inside out. So it's f of 6. So I'm taking a 6 and I'm plugging it into f, and I get a 7. So what I'm going to do is, as I write this out, I'm going to say, well, I'm going to replace my f of 6 with a 7. Right? So now I want g of 7. So now that 7, which was an output, becomes my new input into the g function, and when I take a 7 and I plug it into g, I get a 3. So my final answer is a 3. Go ahead and erase this. All right. I. So I kind of combines what you did with D and E with what you did with G and H. So if you just kind of combine all of those ideas, you kind of get I, and I guess we maybe could have like cubed it, and that would have worked in F, but whatever. So for 9I, what's happening is we're still working from the inside out. All right. So the inside is saying F inverse of 6. Right. So what is F inverse of 6? That's saying what is the input into F that when you plug it into F, you get a 6 as the result. Okay, we're going to figure out what that is. Then we're going to take that answer that we get, and then we're going to say, all right, well, that result, that answer is the result of plugging something into the G function, and what is the input into the G function that gets that number that we're going to find. All right. I'm going to do this below because I'm kind of at the edge of my screen here. So I'm going to leave the G inverse. I'm going to leave that alone because we're working from the inside out. So I'm not even going to think about the G function right now. And I'm looking at just F inverse of 6. Well, it actually turns out we answered this for 9D, but I'm going to do it again. So what is the input into F that results in a 6? right? There's some input into f that when you plug it in, you get a 6. What is that input? And the answer to that question is 9, right? So 9 is the input that you plug it into f, you get a 6. Now I want g inverse of 9. So now I'm looking at the g function, and I'm saying, I get a 9. What is the input into g that results in a 9? And the answer to that question is a 1. So g inverse of 9 is 1. And that's my final answer for I. And that is how we evaluate functions from a table. Notice that we have just straight up evaluations. We have inverses. You can certainly raise it to a power or otherwise manipulate it. And then we have composition of functions. And we're going to want to be comfortable with that because it is going to pop up in class this year.